This recording is for SAT Math, Providence Baptist Church. This is the October 21st lecture. I'm going to dispense with a little bit of the preliminaries, the homework problems, as well as the Princeton review problems. We're just going to go directly into the lecture up to and inclusive of the beginning of word problem, because I'd really like to get into that during our session on Saturday. So let me share my screen. So what you are going to get are actually the notes that I lecture from. And there's a reason for this. So let's go with the first problem that we went through in both classes. We're solving equations by cross multiplication. If you notice in the first step, given 10 over 3 is equal to 8 over 6, solve for x. I state multiply the first numerator times the second denominator. So multiply the 3 times the x. Multiply the second denominator times the first numerator. And here we do that step. So you've got 10 times 6 is equal to 3x. 60 is equal to 3x. Your next step is to divide both sides by the x coefficient, 3, and then you will get x is equal to 20. So that is the first problem. Similarly, on the second problem, you have a little more complicated fraction where you have 2x plus 7 over 3 is equal to 5 over 2. Solve for x. You do the same thing in the first step. You multiply the 3 times the 5, the 2 times the 2x plus 7, which you do here. And then you distribute the 2 to drop the parentheses on the left side. And you multiply the 5 times the 3 on the right side. So you have 4x plus 14 is equal to 15. Then your next step, you're going to subtract 14 from both sides, which we do here. And then, of course, you're just left with 1. 4x is equal to 1. And then you divide both sides by 4, and you get x is equal to 1 over 4. This one, which Saturday I wrote this as x, so I apologize for that. If 3x plus 2y over 17 is equal to y over 4, what is x over y? Both classes did pretty well on this, but of course, we're going to go through the same steps. Multiply the numerator, multiply the denominator times this numerator, multiply this denominator times this numerator, cross multiplication, basically. And then when we distribute the 4 inside the parentheses to drop the parentheses, we get 12x plus 8y is equal to 17y. The next step, we're going to subtract 8y from both sides of the equation. And that leaves us on the right with 9y and on the left with 12x. And then the next step, you divide both sides by y. That leaves you with 9 on this side is equal to 12x over y. And then you divide both sides by 12. So now you have on this side, x over y is equal to 9 over 12. But you notice that 9 and 12 are multiples of 3. So then you can cancel 3 in the numerator and the denominator, and you're left with the answer 3 over 4. This is the part where we talked about linear equations with one solution, no solution, and an infinite number of solutions. And I'd like to explain this slowly. So we're going to go through the first one with one solution. Solve the following equation. 7x minus 6 minus x is equal to 12 plus 2x plus 10. So this first step is you combine like terms on both sides of the equation. So you notice that 7x minus x is a like term. 2x is by itself over here, and you've got constants 12 and 10. So then you add like terms. You get 6x minus 6 is equal to 2x plus 22. Then you add positive 6 to both sides of the equation. So that's going to give you 6x equals 2x plus 28. Then you're going to subtract the 2x from both sides of the equation. And that's going to leave you with 4x equal to 28. The rest is simple. You divide both sides by 4, and that leaves you with x is equal to 7. Of course, that's 4 steps. And that is one solution. Now we're going to go into no solution. And we're going to go a little bit deeper into this, into the problem that I introduced after this problem but I'm actually just going to do it a little bit later in this version of the lecture. Solve the following equation. X plus 5 plus 3x is equal to 6x minus 2x minus 6. Step 1, combine like terms on both sides of the equation. So we're going to combine the x and the 3x. We're going to combine the 6x minus 2x. So now we have 4x plus 5 is equal to 4x minus 6. And both classes tried to work it out, but there are no other steps. This is the equation that has no solution. If you subtract 4x from both sides, then you have to ask yourself, does 5 equal minus 6? No. You add plus 6 to both sides. Does 4x plus 11 equal to 4x? No. If you subtract 5 from both sides, does 4x equal to 4x minus 11? No. And the reason why is because this equation has no solutions. So we pointed out the characteristics of such an equation. The x coefficient is the same on both sides of the equation. This is 4x, this is 4x. The constant on each side of the equation is different. So both equations are in the form y is equal to mx plus b. Of course, y is equal to mx plus b is the equation of a line, where m is the slope. In this case, the slope of both of these equations is 4, and b is the y-intercept. In the two equations, the slope is it, like I said that, I've already said that already, but no solution means that there are no points where these two lines intersect. Therefore, they are two parallel lines. And what I'd like to show you on my calculator, and I'm going to switch our view to the calculator. So if everybody can see that, first I'll clear this, and then I'm going to go here. So if you can see, I've already typed in the equations. Those are the equations that we said had no solution. If you notice, one has a positive constant value, one has a negative constant value. So when I hit this button, trace, this is the actual representation of the equations that have no solution. 4x plus 5. So again, 4x is the slope, 5 is the y-intercept. At 4x minus 6, 4 is the slope, minus 6 is the y-intercept. These are two parallel lines that will never intersect. And that's what we mean when we say that this equation has no solution. Now we're going to go into problem number 6, which has an infinite number of solutions. So we said solve the following equation: 3x minus 9 plus 5x plus 4 is equal to 11x minus 5 minus 3x. Step 1 is to combine like terms on both sides of the equation, which we go through, and what we find is x minus 5 is equal to x minus 5. Okay, so we have equations of a line, but they're exactly the same thing. This is a true statement. So for every value of x, whether you make x equal to 0 or you make x equal to 1,000,000 or infinity, it will all work. Therefore, we say in this case, there are an infinite number of solutions to this problem. So this is the one that I introduced in the lecture earlier, and that's what I mean by this verbiage. But let's go through it. In the equation below, k is a constant. What is the value of k if the equation has no solution? So in this example, which is a problem that was on the recent SAT, this is 9 times quantity x plus 3 minus 32 is equal to 24kx plus 4. So remember, what are the characteristics of such an equation? The first characteristic is that the x coefficient has to be the same on both sides of the equation, and the constant on each side of the equation has to be different. The first thing we do is multiply the 9 times the x plus 3, and then we get 9x plus 27 minus 32 is equal to 24kx plus 4. Or we get this, 9x minus 5 is equal to 24kx plus 4. Now, if this was equivalent to this, our second condition is met. We basically have two y-intercepts, minus 5 plus 4. But how do we get the value of k? What we do is we equate the x coefficients. 9 is in front of this x. 24k is in front of the other x. So then we solve for k. 9 is equal to 24k. We solve for k by dividing both sides by 24. We get 9 over 24. And we know that 9 has multiples of 3, and 3 times 8 is 24. We can cancel the 3's, and we get the fraction 3 over 8. And so if we plug 3 over 8 into this equation, what we will actually get, this means the 24 cancels, and you're left with 3, and 3 times 3 is 9. 24 cancels with the 8. So you get 9x minus 5 is equal to 9x plus 4. So what you have are two lines, similarly to what I showed you on my calculator, that have the same slope, but one line has a slope of -5, a y-intercept of -5, and the other one has a y-intercept of +4. So therefore, the value of k that makes the equation have no solution is the fraction 3 over 8. And this is where the video will stop, because we only went this far in the lecture. And I'm just going to review it again for your viewing to prepare you for the remainder of the problems, which will be word problems. An increasing number of problems on the SAT are word problems. The following steps will help you solve word problems. The first step is read the problems carefully and avoid misreading anything important. The second step is to identify the key values and determine how they are related mathematically by converting the words to math. Under that step, it is necessary to define the variables and create equations to represent relationships. State in words what the unknown is. I bolded that and I underlined that for a reason. And what you're going to see on Saturday is that we are going to do this by basically just creating tables, filling on one side what the words say, and on the other side, what we can relate it to mathematically. And then carefully determine the equality, identify what goes on the left side of the equal sign and what goes on the right side of the equal sign. Third step is solve the problem and interpret the solution. Fourth step is make sure that the answer is reasonable. Ask yourself, does it make sense? Does it answer the question that was asked? With this warning, beware of possible changes of units in the problem. Information in the problem may be in one unit, while the question to be answered may be in another unit. For example, the information in the problem may be in feet, but the question to be answered may be in inches, or because you guys are more hip to this than my generation was, you may be asked the question in meters and have to convert it to centimeters or vice versa. So I am going to stop this recording, and I'll see you on Saturday.